here's our sine. Now, if you remember to find the inverse, it has to pass the horizontal line test. If you think of sine, does it pass the horizontal line test? Not at all. So what we do in sine so that it passes the horizontal line test is we change the domain to negative pi over 2 to pi over 2. And now, if we think about the graph of sine, that would be from negative pi over 2 to pi over 2, and it's just that graph. Now, we don't usually think about it this way. All of you have thought about it this way when you did triangles, because you remember how never find the largest angle with the law of sines, because if it's over 90 degrees, you won't get the right answer, right? That's what we're doing here, right? Remember, if you think about the unit circle, right, if we have our unit circle, you'll remember inverse sine only gives us answers over here, right? That, hopefully that rings a bell a little bit. Yeah. So that's what this does. So what that does over here, my range for my inverse is negative 1 to 1, and my domain, and my range is this. So when you do inverse sine, you only get answers from negative 90 to 90, which is this right half of the unit circle here. Okay. All right. So trying to remember that. Now, I want to mention here, we use sine to the negative 1 to be inverse. Sometimes you will see some places will use arc sine to represent inverse sine. For example, if you're on Wolfram Alpha or some of those online calculators and things, they will use arc sine instead of sine to the negative 1, because sine to the negative 1 could be misconstrued as an exponent, even though it's not, it means inverse. So that they use arc sine so that you don't have that confusion. Okay? I like using sine to the negative 1. That's just what I prefer to use. Okay? So if we remember that idea, we could come down here, and if we remember, if we look at sine to the negative 1 of square root of 3 over 2, you are thinking, what angle has a y-coordinate of square root of 3 over 2? This is like unit circle stuff, right? You think of unit circle, what angle has a y-coordinate of square root of 3 over 2? It's the y-coordinate, would be the long one, so it would be 60. 120 would also have the same coordinate, but that's on the left side, so we couldn't use it. So, but we only use radians. Yeah. We're not in physics, which uses degrees. We only use radians. So pi over 3.
Is that the derivative?
Oh, we haven't got the derivative yet. This is all pre-calc review.
Okay.
So what happens if I had sine of pi over 6? Is that inverse? No. So that would just be, what is the y-coordinate for that angle? And what is pi over 6 in degrees? 30. So what is the y-coordinate at 30? Let me get to it. Okay. So these are our two kind of problems. You can either find the sine of an angle, right? If you remember from pre-calc, the sine of an angle is a y-coordinate, and inverse sine of the y-coordinate is the angle. That's the back and forth. Okay. All right. So now we're ready to find the derivative of inverse sine. Okay. So let's go about how we're going to prove this. Okay. Now, at this point, we're not going to go definition of derivative. The limit as h goes to 0 of f of x plus h minus f of x L over h. We don't have to use that. We are going to use implicit differentiation. So if I have y equals the inverse sine of x, let's write that not as an inverse, but as a sine. So I'm going to go back to this right here. Consider this right here. If I have the inverse sine of the y is theta, let's make this an x and that a y. And then that will make this y an x. Does that make sense? So here, I can say x equals sine of y. So now, take the derivative of that. Take the derivative of that with implicit differentiation. You just did the project. You should all be able to get that, right? Yeah. So take the derivative of that. Try it. And anytime you take the derivative of y, it has to kick out a dy dx. So derivative of x is just 1 equals cosine of y dy dx. So dy dx is equal to 1 over cosine of y. It will be, but we're not going to go there yet. What we want to do is we want to write the derivative of inverse sine in terms of x. We don't want a y in our answer. Because this is a function, and we want to be able to do it as a function, not implicit. So we're going to simplify this a little bit. I'm going to pull out a few things kind of out of thin air that you may remember. Okay? Do you remember that cosine squared plus sine squared equals 1? Okay? So that means cosine squared equals 1 minus sine squared. So far, so good? Am I able to take the square root of both sides and say cosine of x is the square root of 1 minus sine squared?
Yes.
Am I able to do that?
Yes, you are.
Are we sure?
I think so. As long as you leave it like that.
Now, think about this. What happens if, see how well we know our unit circle. What is cosine of 120? Luke picked 120 earlier, so we'll just say with that.
That's the x value.
It's the x value. What's the x value of 120? That's the y coordinate. Positive or negative 1/2?
Negative.
120 would be negative 1/2, right? Can the square root equal a negative?
No.
No. So this is not true at 2 pi over 3 or 120. So this is not always true. This would only be true if cosine was what? Positive. Cosine has to be positive. Well, what of the 4 quadrants, what quadrants is cosine positive? 1 and 4. Okay. Based on doing inverse, where is inverse defined? 1 and 4. So we know cosine's positive because we're dealing with the inverse. So that means that we know that this is true, which means I can change this to 1 over the square root of 1 minus sine squared y. Now,
Why do you want it?
now,
We're getting there.
what is sine of y? What is the sine of y? X. So this is equal to 1 over the square root of 1 minus x squared. There is our derivative of inverse sine. 1 over square root of 1 minus x squared. Now, yeah.
So cosine of y won't always equal square root of 1
it works out because the inverse is always defined as being a right side only.
But there's some problems where it doesn't.
Theoretically, yes. Will that ever impact you at all? No. At this point, other than I'm going to have you do tangent in a second for fun,
You are not.
you will not need to do this. All you need to do is memorize that inverse sine, the derivative of inverse sine is 1 over the square root of 1 minus x squared. And this, I think, when you look at it, kind of blows your mind from this standpoint. You're taking the derivative of a trig function, and your answer has no trig functions in it. That just kind of doesn't make sense. So I kind of went through this so you can kind of see where that comes from. Okay? All right. So, let's think about inverse tangent. Okay? I don't think you have, is there anything in the back?
Yes.
Okay, let's go to the bottom.
It's hard.
Let's go all the way to the bottom.
Off the back.
We're going to see if we can figure this out ourselves. So we get x equals tangent of y. So down at the bottom, you have the bottom half there.
Why is it y?
Here, because we're taking the derivative of inverse tangent. So this is like dy over dx. This is our y. So now, you get x tangent of y. We'll kind of work through it, see if you can figure it out. Take the derivative of that implicit differentiation, like we did before. I'm going to go back so you don't have to flip back and forth.
What is the secant squared x tangent squared x?
No, derivative of tangent is the one you have to know,
Yeah.
right?
Squared.
Secant squared.
Alright. 1 equals secant of y.
You're the auditory person, right?
I think I'm a little bit of everything.
Well,
But the auditory consistent and center.
That's actually, nobody likes to talk about that in education, but most research shows the whole visual, auditory, kinesthetic learners things is all completely made up and not true.
I definitely feel that.
That's not true at all.
I also learned by all three.
Everybody's all three,
Right.
and using all three will help you. Nobody's like really, nobody's an auditory, nobody's kinesthetic or
Aren't you
visual.
the one who gives us that quiz at the beginning?
Yeah, that's, like I said, that's a big thing in education, that's the way you're supposed to learn. But there's no research. Basically, one psychologist came up with that like in the 1920s, and everybody's gone with it. And there's no scientific proof that there's anything to that. So, all right. Do we have the derivative? What'd you get? 1 over secant squared, right? Of y, right? So, if we use the same thing as here, right? Wouldn't secant squared y be the cosine of y? So right on the bottom, you have 1 over.
What?
So we get to here, right?
Oh boy. Here we go.
You get to there, right?
Yes.
So we have y. We gotta use our same kind of idea here to simplify this. Okay. So the difference is this is squared, right? So because it's squared, this is going to go away. Okay, but let's go back to it. Do you remember your fundamental trig identities? So we have,
Hang on,
do you remember those?
hang on. I might have a paper somewhere. I might have a
Do
paper.
you have your formula paper? Okay,
Sarah's got it.
so it's what? What is the secant squared?
Yeah.
Is it on there?
Yeah, it's like.
It's secant squared is equal to
1 plus tangent squared.
1 plus tangent squared.
Are we gonna end it?
Okay. Okay. So this is 1 plus tangent of y. So what is tangent of y? What is
Sine over
tangent of y? X.
X.
So this is just 1 plus x squared. So that is our derivative. The derivative of inverse tangent is 1 over 1 plus x squared. So, no, this is just, you do not, all that we went through here is just to show you where it came from. All you need to know is this. The derivative of inverse sine is 1 over 1 minus x squared. The derivative of inverse tangent is 1 over 1 plus x squared. Everything that we have talked about for the last 15, 20 minutes, you can forget all of it and just memorize that.
Are those the only two?
Yes, we're going to talk about the back, and really these are the only two.
Oh, the back's kind of fun.
I'll talk about the back in a second, okay? So let's do an example. What would be the derivative of inverse sine 3x squared? So first off, what's the derivative of inverse sine? 1 over 1 minus x squared. But x squared is the 3x squared because the inside stays the same by chain rule. Right, that's the inside. So the derivative of the outside, inside stays the same, times you could put 6x on top
Makes me feel better.
if you want to do that. And if you really wanted to, you could also get rid of the squared on the bottom. Okay. All right. So this is now you're just using chain rule, all that kind of stuff. Okay. So here are these two. Derivative of inverse tangent. I just showed you that. I'm not going to go through the derivative of inverse secant. Just write it down.
Oh, crap.
Absolute value of x times the square root.
You guys can come in.
I am
Beautiful.
not going to prove that one,
Thank you.
and I am not going to make you memorize that.
You really want to
Thank
prove
you.
it, right?
He doesn't know.
Yeah, he doesn't know. He wants to know now. He wants to.
You do it the same way, but you have secant. What's the derivative of secant?
Inverse sine.
No,
Derivative of secant is secant tangent, so it's a little more complicated with that. But it works the same way, okay? Now, so this is one I'm not going to ask you to memorize. We're just, only ones we have to know are inverse sine, inverse tangent. The others we'll look up. So, now these. Here are the other ones. Inverse cosine, inverse cotangent, inverse cosecant. These are on the back. Once again, I'm going to show these to you, but we will never use these.
Why?
Here's why. If I have an inverse cosine, I can just rewrite inverse cosine as pi over 2 minus inverse sine. So the reason why this is let's say we have this. Let's say we have a theta, and I'm just going to make up x, y, z because we don't necessarily know what the numbers are. We have x, y, z. And we want to find d theta dt. We want to figure out what that is. We could write sine of theta. We could write tangent of theta. We could write cotangent of theta. So you have a choice. I'm going to probably pick tangent. Okay, you'll see what I mean in a second. So I'm going to pick tangent because then when I solve for tangent, I get inverse tangent. So I have to take the derivative of inverse tangent. And the derivative of inverse tangent is 1 over 1 plus x squared. You could do this problem by doing cosine and do it that way. Or you could do it, wouldn't be x over y, cosine would be y over z. Or I could do it by doing inverse sine, which would be x over z, right? So you could do it by any one of them. We're never going to pick cosine. We're always going to use sine or tangent. And most of the time, I'll probably even pick tangent if I have a choice, because tangent doesn't have the square root in it, which just makes things a little bit easier when there's no square root. So a lot of times when we're solving triangles, and this is down the road, next chapter, when we solve triangles, you have a choice. So we never pick these. We always just go sine or tangent. So these are just kind of defined in terms of that. So the only two we really need are sine and tangent. Okay? What's that? No. Okay. All right. Thought there was one in your notes there.
There it is. We have p
Where's it at?
x squared,
Right.
inverse tangent, 2x inverse. That's just parentheses.
All right. All right. That's on the back. You didn't have it in my notes? Take the derivative of that. 2x times inverse tangent of 2x minus 1 plus 3x plus x squared times 1 plus 2x to the negative 1 plus 3x squared. There's the derivative of inverse tangent with the inside staying the same times the derivative of the inside, which is minus 2x to the negative 2 plus 3.
If you put that on top of it,
That would be fine. Put it on top.
you can put bx squared as x plus the negative 2x.
You can put all that up top if you want to.
Oh, I forgot about